profile to grab the link and drop it in the chat so we can share. Just give me a minute. And then Peter, I'm going to send it to you. Cool. For everybody who's tuning in, thanks for being here. This is our first live stream of Everything Bagel. So you've probably started to see that for my podcast, The Index, we've got a couple sub segment shows. This is Everything Bagel. This is my co-host, Bidhan Roy, who is the co-founder of Bagel Network. I'll let him introduce Bagel in a minute. And we've got our guest here, Peter Voss, who comes from Nagoya. We had him on my podcast previously. Some of you guys might recognize his name if you've been in the AI space for a while. He was one of the co-authors of a book where they originally coined the term AGI, and his company's fascinating. They're working on cognitive AI, which is slightly different than, majorly different than the LLM way of building AIs. We wanted to do a live stream today because Bagel, everything Bagel, we focus on AI, everything open source AI and at the intersection of AI and crypto. And Bagel has built a technology that is really important in the stack of building really people-powered, community-owned AI. That is, what they do is monetizable open source AI. So they enable you to monetize your contributions to open source AI. We just wanted to create a space for everybody to have conversations about the latest and greatest in the research in the AI space, and felt like it was a good opportunity to do a live stream, especially with the DeepSeek, shakeup, earthquake that just hit the markets and the AI space. But before we get too far into it, Bidhan, I'd love for you to maybe just say a little bit about yourself and about Bagel, and then we'll go over to Peter.
Happy to. Thank you for the intro, Alex. Bidhan, my name, that's how you say it. And the founder of Bagel. And at Bagel, we make open source AI monetizable because we believe that open source has been, in general, open source and open source AI has been this altruistic effort or this gift-giving economy, which did not really work for the small players who doesn't have a lot of resources to be able to contribute to this economy. And we want to change that. And we are building an infrastructure using cryptography to solve that problem. And my background is machine learning and been also in the cryptography industry for a while. So really bringing those experiences together in this project.
And Peter, you want to just give a quick hi and background?
Yeah, hi, I'm Peter Voss. I'm founder and chief scientist of Aigo.ai. And I've been working on artificial general intelligence for more than 20 years. Really, our focus right now is to take our technology all the way to full human level AGI. Our approach is very, very different from what everybody else, or almost everybody else, is doing. That ours is a cognitive AI approach, small data, small compute, more like the human brain that uses 20 watts and can learn with a few million words and not 20 trillion. So that's what I'm doing.
Cool. Fascinating.
Yeah, I want to get into that further, especially have like you and Bidhan swap stories and insights on that. Because I think Bidhan, you've worked more with in the LLM space than obviously with the cognitive model for developing AGI. But before we get into that, I kind of want to hear both of your takes. Maybe we can start with Peter, just on DeepSeek. Like, what's your opinion, or what do you think about the recent events with that coming out and the results they were able to generate?
Well, I think it just highlights, again, when you have a small team with relatively limited resources, they basically need to work smarter. Whereas I think what we've seen is that the big companies had so much money thrown at them, and that's their mindset is basically the more money we have, the more compute we have. That's our moat. And as a small team, you basically just have to be smarter. And I mean, we've seen it again and again, where the big companies basically get overtaken. Whether it was Google or Amazon or whatever. And I think as Gary Marcus quite correctly analyzed it, it's not that the technology has moved forward in terms of what it can do. It's just that it needs a lot less compute, a lot less power. So it makes it more accessible, makes it accessible to more people. And the fact that it's open source is also great. I mean, people can basically take out the reasoning engine and maybe apply it to other models. They can, you have a lot of flexibility. So I think it's fantastic from moving the technology forward, making it more accessible. I don't think it does anything towards getting to AGI, but that's obviously a big topic by itself. But it's a huge blow to these big companies, that are 150 billion um, dollar valuation and trying to get to $1 trillion valuations. How they're going to justify that is going to be really hard.
Interesting take. Bidhan, I think it would be really cool for you to kind of, I would love to hear your opinion just generally, but also just how can you leverage this in Bagel, and how can people work together to improve it and earn money that way? I think that'd be kind of a cool
Hmm.
walkthrough example that will help Peter understand kind of what you're building and how it works.
Yeah, definitely. First of all, I totally agree with Peter that when you don't have a lot of resources, you have to be creative. You have to use your talent to overcome the barrier which is created by your competitors who probably have a lot of money. In this case, DeepSeek had competitors who had a lot of money and they had a lot of GPUs and compute to throw after the problem that they had, right? But they had to figure out a way where they kind of squeeze out the maximum amount of performance off of the model that they're building. They used some distillation from the bigger model, so they had some advantage there. But even then, like when you have the necessity but don't necessarily have access to the resources, you have to be creative. And that's kind of similar area where we started. Like open source AI is a necessity. We want open source to win. We want open source developers to come together and build better models than the state-of-the-art labs. But how can we allow them to do that? And that's why we tried to be resourceful and we wanted to build this infrastructure that we are building. So that's basically the inspiration behind it, which is, I think, is very similar as DeepSeek. And in general, how open source models can be utilized, how open source model can be utilized in the Bagel infrastructure so that they can be monetized, is that we built this new architecture for models where open source contributors can contribute their spatialized information through private adapter layers. They can be like a LoRa adapter, or they can be some other kind of adapters. They provide that, but at the same time, that adapter layer stays private to them. But they can prove with zero knowledge cryptography to a base model owner that they actually improved that certain model in that certain domain without necessarily revealing the weights. So it's like this kind of interesting marriage of cryptography and machine learning. And why it's important that we think is that if you have ownership through which is enforced by cryptography of the contributions, then when an inference that is being made on that model has to go through the rules you set for it. It can be something like you allow certain people to use that model, or it can be you put a rule where the user have to pay a certain amount to be able to do so. So that's kind of the overall view of how that can be worked. And the models like DeepSeek are very well suited for this infrastructure because they were built in a modular way as well. Because they're this like MOE infrastructure, mixture of experts, where the small experts can come in. And these can be adapted to the Bagel infrastructure in a way where an open source contributor can contribute a certain expert to this infrastructure, but then they have the full ownership and control of it, and they don't have the downside of that being copied by anyone and being used without their permission. So I'm gonna stop. I can go forever on the technicals on it, but that's kind of the bird's eye view of what we do and how models like DeepSeek fit into our solution.
So This, and Peter, jump in if you have questions for Bidhan or anything you want to ask him. But I like, you said something really interesting, both of you guys did, about accelerating to AGI and how you don't think DeepSeek really gets us any closer. And so I've been asking myself this a lot the last couple of weeks, especially as we've been making this show with Bagel. What are the components that do accelerate us to AGI? And second part of that is, can we build it on open source, like using open source software on public crypto networks, right? I think because I believe that that's important. Like if the community can accelerate towards a truly open source AGI or ASI, that's important for humanity, for it to be available to everyone. So I ask you, Peter, and Bidhan, like, what are the components and how do we accelerate? What's needed to get there faster?
Yeah, so I think I agree with Jan LeCun, who made a very strong statement a few months ago. He said large language models are an off-ramp to AGI, a distraction, a dead end. Those were his exact words. Pretty strong statement, and I agree with that. It's basically a distraction. Large language models cannot get us to AGI. And there are a number of technical reasons, but probably the one that's most easily understood is that large language models cannot learn incrementally in real time. And that's inherent in their nature. When you have backpropagation, you basically need a large data set that you need to number crunch and backpropagate. So they cannot update their model in real time. And we can have a debate about that. I'm co-author on a paper where we actually reviewed more than 200 research papers, people trying to do incremental learning, and none of them, not a single one, actually can update the core model. Can't be done, basically. So but there are a couple of other reasons, and as I said in the introduction, there's also fundamentally kind of it's an insane approach. I mean, it's a desperate approach. Basically, the large companies have a lot of compute, they have a lot of data. That's a hammer they've got, so that's the approach they use. Looking for nails. But when you think about our brain using 20 watts and a child being able to learn language and reasoning with maybe a few million words, not 20 trillion, you kind of gives you an idea that it's fundamentally the wrong approach. So what I believe we need to get to AGI is cognitive AI, basically where you start off by understanding what makes human intelligence special, and being able to form concepts directly in real time on the fly with limited resources is kind of a key requirement for that. So I think that's what we need to get to AGI, is more people working on the right approach. Now, in terms of how we could use blockchain, how we can have open source, unfortunately, I cannot think of a way of really making cognitive AI very modular. I don't think it can be done. The modules need to be deeply integrated. So you need to have a kind of a neurosymbolic architecture that is deeply integrated, where the various components that you have actually support each other and work closely together with also the knowledge representation that you have. So you really need, I think, an integrated whole. However, where I do see, similar to what you're doing now, is that you have expertise that you can train. So there are particular domains that you could train the system with additional knowledge, and you could probably figure out a way that that knowledge could then be licensed, and people could pay for the usage of that knowledge within an AGI. And in fact, I'd love to see that, where once AGI architecture has been built, it's then the knowledge that somebody can train the system with, that would be the part that can be licensed, and you can still have that whole thing in a kind of an ecosystem of people contributing their expertise.
So Peter, quick follow-up question on that. So when you say cognitive AI, so does it mean something similar to a Hebbian learning, or it's like totally new? Like as you mentioned, that it does not have the requirement of doing backpropagation. So I'm guessing it's not like transformer architecture.
Correct. It's not a transformer architecture because transformers really commit you to backpropagation. Yes, Hebbian learning is our brain has very simple mechanisms. It's basically pattern recognition, and yes, fire together, wire together. Hebbian learning is certainly one of the mechanisms that you have to learn associations. But of course, it's a little bit more sophisticated than that. That you can learn whole continuous patterns, and the system can recognize patterns. It can generalize patterns. It can use patterns to predict things and learn associations. I mean, that is ultimately how our brain allows us to do these magical things to like us having this discussion here.
So it's very interesting. So would you say that even the hardware required for this kind of system is different? Because historically, the kind of hardware that was developed, that kind of developed in tandem with the software solutions, like for AI, right? So
Right.
it was like very specific for the solutions that we had, like transformers and whatnot. But what kind of hardware do we need for this new architecture that you are working on?
So we use off-the-shelf computers, but inherently because it's incremental learning, it doesn't need to compute 10 trillion pieces of information. It literally learns sort of one sentence, one input at a time, while using context as well. So the computational requirement is massively, massively less than what you need for deep learning and large language models. So we are using off-the-shelf computers. Um, we are, we clearly not at adult full human level AGI. If
Hmm.
we were, we wouldn't be having this discussion here. We'd be $1 trillion company. Um, but as we're working through now,
I'd
we
like to think
basically
you'd
work.
still come on my show though, Peter. Even at $1 trillion, we'd still get you on.
All right, good. um, so we are basically teaching our. Currently, we're teaching our. We had a commercial version of our product that operated at adult level for very narrow applications. Where one of our big customers, 1-800-Flowers, Harry and David group of companies. And last Valentine's Day, we replaced 3,000 agents. So there it was operating at adult level, but it had a lot of human coded knowledge, which is not what you want for AGI. And it was, very narrow in its application. So we actually put our commercial business on hold 7 months ago to focus 100% on building AGI. So what we did is we stripped out all of the hard-coded, all of the human-entered rules and stuff, and we are now training the system at a 3-year-old level, 4-year-old, 5-year-old level to learn language and to learn reasoning the way a child does. And of course, a 3-year-old is not very impressive. So if people say, well, what can your system do better than large language models? Well, nothing. What can a 3-year-old do that's better than large language models? Not a lot. Um, so we are working our way up, and right now, I mean, we train our system in minutes on a standard off-the-shelf computer. That's how little compute it needs. Now, as the knowledge base grows, um, from our previous experience, we believe we can run human level, full adult level intelligence on an off-the-shelf computer. I don't think we'll need anything super exotic. We don't even use GPUs at all now. We could probably use GPUs,
Wow.
to accelerate as we scale up for some of the calculations we do. But it really is many orders of magnitude less computationally intensive than large language models.
So it's interesting because you mentioned knowledge base. So I'm assuming some kind of multi-dimensional latent space, which is the knowledge, and that stays outside of the model. And I'm asking you because you mentioned that you don't know how blockchain or cryptography or crypto tech can be used. Maybe there's a use. So I'm like, that's why I'm trying to understand how you guys are leveraging it. And if it's like proprietary information, of
No,
course,
no.
you don't have
I
to
mean,
share.
I have certainly have published overview of how we go about it. So the core of our system is a super high performance knowledge graph, a vector knowledge graph, and it's literally 1,000 times faster than any commercially graphed database that you can get off the shelf because we custom
Hmm.
built it for our purpose. And that knowledge graph contains not just the knowledge, but also the skills that the system has. So it's again integrated between skills and knowledge, on how to do when you teach it how to do something, how to book a flight, or how to solve a puzzle, or how to do a maze, or whatever it might be. The skill to do that, the mental skills, the physical skills, and the knowledge are deeply integrated and both encoded in this uh, uh, graph vector graph database. Um, Now, that part couldn't run on the blockchain, that wouldn't just from a performance point of view. But there could be knowledge that is acquired, customized knowledge, specific knowledge. For example, if somebody's an expert in helping people manage stress or addiction or whatever it might be, or and how to run QuickBooks, or it could be anything,
Yeah,
Excel, and they teach the system that knowledge. You could certainly figure out a way to index that and key it off a crypto key that when people
hmm,
access that knowledge, that they would get paid for that usage. That I can see that totally viable.
yeah,
Also, the other part where I see um, blockchain potentially being really useful is of course for the whole ownership and privacy, because I believe that AGI should be owned by individuals. And with our block,
correct.
because it can run, because it can run on a phone, basically well, maybe not today's phone, but it can run on your own on a local computer. That really people, and soon it will be able to run on a phone. People will be
Definitely.
able to have their own personal AGI, and then I think the security part of it is, that's I think where blockchain could certainly help.
Yeah, definitely. Like blockchains are in general are very resource constrained environments. There's like certain amount of operations you can do on the blockchain itself because it's very expensive.
Right,
But what we do, like even in our solution, we do the computation not on the blockchain. We
right.
do it wherever off chain.
Mhm.
And then there are different ways you can actually prove that you did certain computation in the correct way, and that's where some of the cryptography comes in, and that you can post on the blockchain, and the other participants in the economy can come in and they can see that you did the computation, but they don't necessarily know what computation you did or how you did it. So it's kind of the similar way, like goes to where you mentioned that people should have ownership and privacy. Like, in your case, the architecture you're utilizing, people are, let's say they're providing knowledge,
Mhm.
the certain knowledge base that's like very own to themselves. And they can provide it, and they can prove within a blockchain that, hey, I have it, without revealing the actual knowledge itself. And then when a counterparty are interested in the kind of going into that knowledge base,
Mhm.
they can have a transaction, like they can have a monetary exchange. But the blockchain here acts as an trusted intermediary who has the proof that, yes, I have it. Now it's your turn to do the transaction with me. Like that's kind of one way this can be definitely leveraged.
Yeah, absolutely. I think that's a fantastic kind of system to have, so that individuals can actually trade their knowledge and skills with
Yeah,
others and get rewarded. And I think it's fantastic, and I'd certainly like to see AGI implemented in that way, rather than having these mega corporations that control and own everything and have walled gardens. Uh, of course, now with these large language models just plummeting in cost, um, that dream of large companies controlling it is kind of collapsing, because even large language models, it looks like within a few years you'll be able to run a full scale, or maybe even a year from now, be able to run a
yeah,
full scale model, on your phone.
Yeah, I mean,
yeah,
I think one thing the market realized is that the moat is not in the source code, right? Like it's not in the model itself. DeepSeek open source came out open source, proved they could do it for a fraction of the cost,
Mhm.
and the market tanks. And I think I do think the moat is more around the combination of the parts. And if you're open source and you have these monetization engines similar to what Bagel's been working on, that can accelerate the combination of those parts to create something valuable. Is sort of my thesis, is that accelerates the combination of the parts that makes it super valuable. Whether that thing is AGI or a really good LLM or whatever it ends up being, it still gets there faster for less money because like the community was able to contribute to it.
Right, right. There's certainly money to be made in creating specialized agents. Um, it's just, it's not AGI. It's basically there's very much the human in the loop to design the agent. The agent is for something very specific, and um, whenever something changes, a human again has to fiddle with it and fix it, and you still have the problems of lack of reliability and so on. So the grand prize really is to get to AGI, something that has truly human and superhuman all-round intelligence and can adapt in real time to changing circumstances and new knowledge and figure things out by itself.
So Peter, so you don't think we are at the AGI level yet? For example, the kind of models that OpenAI is coming out with, like O1, O3, or whatnot, right? You don't think they're at the AGI level?
Not at all, no. And as Alex said, I actually coined the term together with two others, Ben Goertzel and Shane Legg, in 2002. And the idea was, in fact, why I particularly like the AG and the G, little g, lowercase g in psychology actually stands for general intelligence in, IQ tests and so on that gives people intelligence. And a key part of intelligence and human intelligence is to be able to solve novel problems given insufficient information, insufficient information, and limited resources.
Mm-hmm.
That's key to it. So there are two components of where large language models inherently fall short. The one is autonomy. You always need a human in the loop to configure the system, to monitor it, and so on. And it's inherent. They cannot be reliable, and they have to be specifically set up with human. And the other one is in fact that ability to learn in real time and to adapt. And so no, we clearly do not have AGI. And the fact that it can ace IQ tests or math Olympiads or whatever, well, if they've been trained on it, first of all, or it doesn't really matter how clever they are in doing specific things. With 20 trillion pieces of information they've been trained on, there's obviously a lot they can do. But you can test very easily that they're nowhere near AGI. You can take a large language model and put it into one of the simplest, lowest level jobs in the world, a call center, which is
Mm-hmm.
what my company has a lot of experience with. You could put an LLM in there. Imagine putting an LLM like you would take a college graduate or even a high school student and put them into a call center. They can learn what to do within a few hours or within a day or two by themselves. They can read the manual, they can listen to other conversations, they can ask a few questions, and then they can do the job. And they know when they need to ask for the supervisor. And, LLMs aren't anywhere near that, just cannot do it. Now, you can train a particular LLM for a particular set of conversations, based on statistical listening to other conversations. But as soon as something changes, you have a snowstorm or something changes, the products change, policies change, business rules change, um, the thing just falls apart.
So
So
if I had to distill that down, it would be the inherent ability to process new information and come up with new solutions to that without necessarily having to be trained on it. Is
correct.
that what's roughly okay?
Correct, yeah. And clearly they need to be retrained. That's what everybody's doing. And that's why, I mean, why do you think companies are spending 200 million, or Elon Musk spent $5 billion building a new data center to
Meta just
train.
announced a $65 billion investment this
Right.
year,
And
right?
just
Like
think, how
2025.
many models are they going to train in that data center before it becomes obsolete? I mean, the data center will, the technology will be obsolete, and for sure in 2 years at the pace
Yeah,
things are going. How many
100%.
models are they going to train during the 2 years? 10 models maybe? So each model costs like what, 5 billion or 1 or 2 billion?
exactly.
How
Yeah.
are you going to get a return on your investment? Now, I can see for, own a Tesla and I'm self-driving, and I could see that it's worth a few $1 billion to really get self-driving to work well enough that you can have a robot taxi. I can see that investment paying off. But for other large language models to spend, $500 million or $1 billion on building a new model, and yet they constantly have to build new models because the existing models cannot be upgraded. They cannot learn. You cannot change their model. So that's why it's not AGI. And let me talk a little bit about also just the vision of AGI. When we have AGI, it really is truly kind of a singularity. It's when the AGI is truly smart enough to do all of the cognitive work that any human can do. You know, when it becomes better at designing an AGI or hardware or whatever than humans are. When you can have a single AGI that can teach itself to become
Hmm.
a PhD level cancer researcher. And now you can make
Yeah,
1 million copies of that and have 1 million PhD level cancer researchers chipping away, pursuing different avenues. It's a complete game changer. So no, it's very clear that we don't have AGI. And again, going back to Jan LeCun, large language models are an off-ramp, a distraction, a dead end.
makes sense. And like going a little bit non-technical in the terminologies a bit, a lot of people are talking about terms like ASI or SSI and whatever kind of combination you can think of. It's probably out there already. What do you think about them? Like, is it just some marketing
Just
tactics?
marketing terms. I mean, it's kind of a joke with Sam Altman. One day he'll say, "Oh, we've achieved AGI," and then the next day he'll say, "We'll have AGI soon, but it's not going to be a big deal." If we have AGI, it's a huge deal. And now that he's got this funding, he says, "Oh, please dial down your expectations 100-fold." We know we're near AGI, so it's purely what he needs to say to get funding and marketing. Now, ASI, super intelligence. I mean, we've had that for decades. We've had calculators for decades that are, superhuman in what they can do. So narrowly to be able to be better than humans is not a big deal. I mean, that's what narrow AI is. We have
Hmm.
superhuman
Yeah.
test computers and Go and protein folding and whatever. Once you have AGI, you automatically have super intelligence. It's really stupid to have a distinction to say we'll get to AGI and then we're going to do some work and we'll get to ASI. No, once you get to AGI, the AGI itself will continually improve, will be able to improve the technology. And it already, I mean, current computers, current systems are superhuman in specific aspects. It's just once you get AGI, they will become superhuman in pretty much everything. Now,
Bidhan, I got
except maybe robotics will take a while. Plumbers and electricians are going to be the last people to be replaced.
totally agree with you on that. Bidhan, we've got like time for maybe like one more question here, and I wanted to just ask you this. As far as DeepSeek goes, you guys are it works in the bakery right now. The bakery Peter is like what there's their product where people can go and like contribute to this. So it's already. Did you guys get it up and running? And how are you seeing that potentially at least accelerate that? Whether it could be AGI or not is up for debate, I think, but accelerate the development of that model within your system. How are you seeing that play out over the next couple months?
I mean, it's first of all, the initial reactions has been great. Like a lot of people are signing up and using it. we have had more than 2,000 people sign up to the platform over the weekend, just Friday and Saturday, just for that. It sounds like a small number, but we're an early product and we are a less than 10 people team, so it's a big number for us. And going forward, how we see it is that it's just accelerating from here. There are going to be more and more contributors, and we are going to productionize some of the very novel and frontier research that we have done into this solution, and that will basically kickstart the activation, which will allow open source developers to group together and build systems like new DeepSeeks. I said this morning on a tweet that we will have millions of DeepSeeks for every country, for every political party, every ideology, every language, every region, every university, every high school. All of us will have DeepSeeks. Or I mean, when I say that, like that level of capability of AI systems. And this is just the start of it.
Yeah, I couldn't agree more. Yeah, and I think the acceleration comment is the thing that I've been thinking about the last couple of days. Peter, you were talking about the capex on the data centers, right? And I don't think this lessens the demand for compute. I think that if they found a cheaper way to make these models, they're just going to make more of them faster now with the same amount. Like if Meta's investing 65 billion in a bunch of GPUs, they're just going to accelerate their how strong a model they make. And I don't know, you guys can validate that for me or tell me I'm crazy. I'm not a computer scientist. So, but it just seems logical to me that like if I can, make a cheaper model faster and better than OpenAI because I have DeepSeek now, I'm going to do that. And I'm just going to because it's a race, right? To who can have the most powerful AI out there. This just feels like an arms race to me. Everybody's trying to get to AGI. Some of them are calling it AGI. It's not really AGI, but either way, it's still a race to who can get the most powerful one. And it seems to me that is just going to accelerate things, and they're not going to slow down how much money they spend.
Oh yeah, I agree. It's by making it more accessible, by people being able to experiment, on their local machines that they can put together. I mean, people are talking about, with a few $1,000 hosting complete system and training it and so on. And that's just going to accelerate. And once you build something useful, then you will want to host it in a data center to scale it. And so absolutely, I think the demand for compute is going to be there. There are going to be more people trying to do more things. Now, how useful they end up being is a whole nother question, because there's still very, very limited practical applications that are actually worth money.
Yeah.
And that's why it's very tricky investing into any of these companies. I think people providing infrastructure and tools and so on, I think are going to be doing well.
I was going to say buy the dip on NVIDIA. That's my thinking. But we're at the top of the call here, so we do have to wrap up. Thank you, Peter, for jumping on. I reached out to you yesterday, and you were kind enough to come on. I've been wanting to get you back on the show. Bidhan, as always, thanks, man. Love hosting this with you. Hope everybody tunes in for the next one.
Thank you.